session of EIGRP Stub configuration. My name is Kedar Dantekar and I am a Cisco certified Network expert in enterprise infrastructure. So if you have any question, then please feel free to mail me on kedardantekar@nittraining.in. So our first task is to configure the EIGRP classic mode on all the routers. So let's start with router 1. So on router 1 we have to advertise the networks 200.100.6.0, 0.0 and 3.0. After that the LAN networks are 192.168.0.0 and 193.168.0.0. Now router 2. So on router 2 we have to advertise network 200.100.0.0, 1.0 and 2.0. Now router 3. So on router 3 we have to advertise network 200.100.1.0 and the LAN network is 194.168.0.0. After that router 4. So for router 4 we have to advertise network 200.100.2.0 and LAN network is 195.168.0.0. Now router 5. So for router 5 200.100.6. 3.0, 4.0 and 5.0. Router 5. Now router 6. From router 6 to 100.100.4.0 and the LAN network is 196.168.0.0. Now router 7 200.100.5.0 and the LAN network is 197.168.0.0. After that router 8. So now on router 8 we will be advertising only one network, which is 200.100.6.0. So on router 8 we are advertising only one network into EIGRP. And now for LAN 8. So for LAN 8 I have already configured the static route on router 8. Also for LAN 7 I have advertised the LAN 7 network into OSPF on router 8. So if I show you the configuration of router 8, show run section IP route. So here we can see that I have configured the static route for LAN 8 network 199.168.0.0. Also for LAN 7 network LAN 7 network I have advertised the LAN 7 network into OSPF 198.168.0.0. Okay, and now after that I have also done the redistribution. So I have done the redistribution of on router 8. So I have redistributed the OSPF route into EIGRP. Also I have redistributed the static route into EIGRP. And now if we check the routing table on router 1, so we can see that router 1 is receiving the redistributed route. He is receiving the LAN 7 network. Also he is receiving the LAN 8 network 198.168.0.0 and LAN 8 network 199.168.0.0 in his routing table. Now after that the second task is to configure the EIGRP stub routing on router 8 so that he will not receive EIGRP queries. Also we have to verify that router 8 should only advertise the static route but not any other routes to router 1. So the task is saying that router 8 should not receive any EIGRP queries. Also router 8 should advertise only static route. He should not advertise any other routes. Okay. So now if we check, so router 1 is currently receiving both the networks. So LAN 7 network we have advertised into OSPF and for LAN 8 we have configured the static route. So the requirement is that router 8 should only advertise the static route towards router 1. So for that now we have to configure the router 8 as a EIGRP stub. So we are configuring router 8 as a EIGRP stub. So we will not receive any EIGRP queries. Also now we have to add the keyword static so that router 8 will only advertise the static route towards the router 1. You will not advertise any other routes. Okay, that means the OSPF routes also. You will not advertise that towards the router 1. Now if we check the routing table on router 1, so here we can see that router 1 is now only receiving the LAN 8 network. So for LAN 8 network we have configured the static route, that's why router 1 is receiving the LAN 8 network 192.168.0.0 in his routing table. So after that we have to configure the EIGRP stub routing on router 8 so that he will not receive EIGRP queries. So same thing, we have configured the router 8 as a EIGRP stub. But now we have to verify that router 8 should advertise the static route as well as he have to advertise the other route towards the router 1. So now the task is saying that router 8 has to advertise the static route also as well as he has to advertise the other routes also. That means the route of the OSPF also. Okay. So now for that, now same thing again on router 8. We have to simply add the keyword redistributed here. Okay, so previously we have added the keyword static, that's why router 8 was only advertising the static route. Now he will advertise the OSPF routes also. So now if we check the routing table on router 1, so now router 1 is receiving both the networks, OSPF also and static route also, for LAN 7 and LAN 8 in his routing table. Now after that we have to configure the router 2 such that it will advertise the LAN 1 network, which is 192.168.0.0 and LAN 2 network 193.168.0.0 to router 3 and router 4. Also router 2 must advertise the LAN 3 network 194.168.0.0 and LAN 4 network 195.168.0.0 towards router 1. So now the requirement is that task is saying that router 8 should advertise the LAN 1 and LAN 2 network towards router 3 and router 4. Also router 2 must advertise the LAN 3 and LAN 4 network towards router 1. Okay. So now if we check the routing table of router 2, so this is my router 2. So if we check the EIGRP configuration, so I have configured the router 2 as a EIGRP stub and I have added the keyword connected. So now after configuring this router 2 as a EIGRP stub, router 2 will only advertise the connected network towards router 1 as well as towards router 3 and router 4 also. So if we check the routing table of router 1, so now we can see that router 1 is receiving the network 200.100.1.0 and 2.0. He is not receiving the networks of LAN 3 and LAN 4 in his routing table. Same thing if we check the routing table on router 3. So router 3 is only receiving the network 200.100.0.0 and 2.0. He is not receiving the LAN 1 network, LAN 2 network, also the LAN 5 and LAN 6 network. Okay, so he is not receiving any networks. He is only receiving the connected networks of router 2. Same thing for router 4. Router 4 is also receiving the connected networks of router 2. Okay, so for that now, so because we have configured the router 2 as a EIGRP stub, that's why router 3, router 4 are not receiving the network. Same, router 1 is not receiving the network of LAN 3 and LAN 4. LAN 3 and LAN 4. So for that now we will use a leak map. Okay, so on router 2, we will create the access list first. So we will create first access list permit and we will permit the LAN 1 and LAN 2 network here. So 192.168.0.0 0.0.0.255 wildcard mask, and now the second one is 193.168.0.0. okay, and now after that we will create one more access list here, access list 2, and we will permit the LAN 3 and LAN 4 network 194.168.0.0 0.0.0.255 and 195 network also of LAN 4. Now we will create a route map, let's say LAN and permit 10. Now we will apply the access list here, first access list. Now we will create the second statement for route map and we will apply the second access list here. Now after that we have to go into EIGRP process, EIGRP stub, connected, and now we have to apply this leak map here and we have to apply the route map. Okay. So after doing this configuration, now we can see that the routing table of router 1. So we can see in the routing table of router 1, now router 1 is receiving the LAN 3 network also and LAN 4 network also in his routing table. So he is receiving the networks in his routing table. Same thing for router 3. Router 3 is also receiving the LAN 1 and LAN 2 network, which is 192.168.0.0 and 193.168.0.0 in his routing table. Same for router 4 also. Router 4 is also receiving now the LAN 1 and LAN 2 network in his routing table. Okay, so after configuring the leak map. Now after that we have to configure the router 5 such that he will advertise the LAN 1 network, which is 192.168.0.0 towards router 6, and LAN 2 network 193.168.0.0 towards router 7. Okay. Also router 5 has to advertise the LAN 5 and LAN 6 network towards router 1. So the task is saying that router 5 has to advertise the LAN 1 network towards router 6 and the LAN 2 network towards router 7. Also router 5 must advertise this LAN 5 and LAN 6 network towards router 1. So for that, now again the same thing. So if we verify the routing table of router 1, so we can see that router 1 is not receiving the LAN 5 and LAN 6 network 196.168.0.0 and 197.168.0.0 in his routing table. Okay, same thing if we check the routing table of router 6, we can see that router 6 is only receiving the connected networks of router 5, 200.100.3.0 and 5.0. Also on router 7, we can see that router 7 is receiving the directly connected networks of router 5, 200.100.3.0 and 4.0. Okay, so if we check the configuration on router 5, so on router 5 I have configured the router 5 as a EIGRP Stub, that's why, and we have added the keyword connected, that's why router 5 is sending the connected networks towards router 6, router 7 and router 1. Okay, so now again the same thing, we have to configure the leak map here on router 5. So first we will create the access list. So the task is saying that router 5 has to advertise the LAN 1 network towards router 6. So for that, now we will create the access list. 1. We will permit the LAN 1 network, which is 192.168.0.0. wildcard mask will be 0.0.0.255. Now we will create the route map here. Let's say LAN permit 10. We will apply the access list. And now we will match the interface here, match interface key 0/1. So the task is saying that router 5 has to advertise only LAN 1 network towards router 6. Only LAN 1 network towards router 6. So that's why we are matching the interface here. Same thing now, we have to create the second access list, access list 2, and we have to permit the LAN 3 network here. Sorry, LAN 2 network, which is 193.168.0.0, and now we will create the second statement for route map. We will apply the access list 2, and now we will match the interface E0/2, which is connected to router 7. So the task is saying that router 5 has to advertise the LAN 2 network 193.168.0.0 towards router 7. So that's why we are matching the interface on router 5 that is connected to router 7. Okay, and after that the task is also saying that router 5 has to advertise the LAN 5 and LAN 6 network towards router 1. Okay, so for that, now we will again create the one more access list. Let's say access dash list 3 permit, and we will permit the LAN 5 and LAN 6 network 196.168.0.0, 0.0.0.255 and 197. We will create the route map here again. So let's say 30, and now we will apply the access list here. And now after that, router EIGRP 10, EIGRP Stub connected, and now we will apply the leak map here. So we have done the configuration. Now let's check the routing table on router 6. So previously router 6 was only receiving the connected networks of router 5. Now if we check the routing table of router 6, so here we can see that router 6 is only receiving 192.168.0.0. okay, so the task was saying that router 5 should only advertise the LAN 1 network towards router 1. okay, so 192.168.0.0. he is not receiving the LAN 2 network 193.168.0.0 in his routing table. Same thing for router 7. So router 7 is receiving the LAN 2 network in his routing table. He is not receiving the LAN 1 network. Also, if we verify the routing table on router 1, so router 1 is also receiving, so I wrote EIGRP, So router 1 is also receiving the 196.168.0.0 and 197.168.0.0 in his routing table, the networks of LAN 5 and LAN 6. So thanks for watching the video. If you have any question, then please feel free to mail me on kedardantikar@nittraining.in. Thank you.